All right, this is Unit 8, Lesson 5 in Geometry A, definition of similar figures. Let's define congruent polygons first. Congruent polygons have all angles congruent and all sides congruent. Okay, so if triangle ABC is congruent to triangle DEF, if I say triangle ABC is congruent to triangle DEF, what I am saying is that angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. Side AB is congruent to side DE. Side AC is congruent to side DF. And side BC is congruent to side EF. That is, angle A is congruent to angle D, angle B is congruent to angle E, angle C is congruent to angle F. Side AB is congruent to side DE, side AC is congruent to side DF, side BC is congruent to side EF. Another way to say that is corresponding parts of congruent triangles are congruent, which we've been using in proofs. Okay, that's a review of what it means for triangles or polygons in general to be congruent. All the sides are congruent, all the angles are congruent. For similar triangles, the definition is a little bit different. Similar polygons. The requirements here are all angles are congruent, so that hasn't changed. If I grow or shrink a polygon, the size of the angles does not change. So if I take this triangle and I copy it using my computer and paste it and copy and paste and grow, whoops, try copying it again, get my software to work the way I expect it to. It's user error, I'm sure. Control C, Control V. There we go. If I grow it, the angles don't get any bigger, right? The angles don't get any bigger. The size of the sides gets bigger. So if this angle is 50 degrees, then this angle is also 50 degrees as measured by a protractor. Okay, so the angles don't change size. But all angles are congruent and all sides are something we call proportional. Okay, that is, the ratio of the sides is the same. So if this side is 3, and this side is 6, and this side is 2, then this side is 4. And if this side is 4, this side is 8, because they all have the same ratio. 3 is to 6, as 2 is to 4, as 4 is to 8. Going the same direction. 3 is to 6, as 2 is to 4, as 4 is to 8. And if you reduce all of those, you'll notice those are 1/2. So this is something we call the scale factor. The scale factor of the larger triangle to the smaller triangle is 1/2. If I invert that, the 6 is to 3, as 4 is to 2, as 8 is to 4, that's a ratio of 2 to 1. That represents a scale factor of an enlargement, as we learned in the last lesson. When the scale factor is bigger than 1, it's a growth. So if I consider the small triangle to be the original, as I did draw it that way, and then enlarge it to a scale factor by a scale factor of 2, everything is twice as big. All the dimensions are twice as big. Okay? Right? So all sides are proportional. That is, they all divide out to the same scale factor. Now, scale factor, there is a little bit of confusion, can be a little bit of confusion. The scale factor is always determined by the new dimension divided by the old dimension. So if I'm changing from small to big, put the big size over the small size. If I'm changing from big to small, put the small size over the big size. All right. Okay. So let's apply this to some problems here. Oh, a little bit of review here. Again, comparing triangle congruence and triangle similarity. For triangle congruence, we had the following postulates. We had side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. For triangle similarity and similarity postulates, here's how we mark those. We mark those by side, side, side similarity, side, angle, side similarity, the tilde character here, angle, side, angle similarity, and angle, angle, side similarity work, but actually we shorten those to angle, angle similarity. That is, if two angles are similar, are congruent, then, and as you know from the triangle triangle angle sum theorem, all the angles of a triangle add to 180. If two angles match, then the third angle must match as well, because the third angle can be found by subtracting the other two angles from 180 degrees. So these are the triangle similarity postulates: side, 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 angle, angle. And we designate these as similarity postulates or theorems by putting the tilde or the similar sign next to it. And let me review just a little bit where the congruence and similarity symbols concur. So we know that equals means equal, having the same value, having the same size. Whereas tilde means similar, same shape. And when I combine those with a tilde over an equals, that means congruent, meaning they are the same size and the same shape, both. Same size and same shape. Okay, so that's where the symbol comes from, and hopefully it makes that clear. All right, let's see what kind of questions you might be doing. We're not going to do proofs yet. That's a later unit. But we're going to answer some questions about similarity. Okay, let's say we've got this situation here. We've got a triangle. Make sure I'm not running short of time here. We've got a triangle, okay, in which I know I've got one side. I'm going to draw a segment that is parallel to the other, right? And I'm going to label some dimensions, some values. Okay. And let's say this is parallel to this. Okay. And let's say this is 2, 4, 6. Let's say this is 8. And this is 8. And let's say this is 5. And this is 10. Are the triangles congruent, and how can you tell? Okay. Well, let's see what we know. We know the ratio of sides needs to be the same. So 5 is to 8, or 5. Well, let's do big to small. 10 is to 5. 10 is to 5. As big, 16 is to 8. As 16 is to 8. And if you examine those, both of those have a ratio of 2 to 1. So they have the same ratio. So there's our side, and our side. Side proportional to a side, side proportional to a side. So we've got side, side, but there's no side-side theorem for similarity. We need something else. Since these two lines are parallel by alternate interior angle, or by corresponding angles, these two angles are congruent. So these triangles are similar. Let's label this A, B, C, D, E. I would say triangle ABC is similar to triangle AED. Make sure the corresponding parts line up by side, angle, side similarity. Okay, all right. And then sometimes you'll be asked to find missing parts. So here's some another example here of a problem you might be asked. Okay, let's say we've got two triangles, and I will forego using the sketch tools. Let's say this side is 6, this side is 4, and this side is 5. And this is similar to this triangle, in which this side is 6, and this side is unknown, and this side is unknown. Okay? Well, remember we can find the scale factor this way. The scale factor is the new divided by the old, and it's going from left to right. The new dimension is 6, right? And the old dimension is 4. 6 to 4 reduces to 3 to 2, or to 1.5. You can do it that way too, 1.5. So that becomes my scale factor. So to go from left to right, I'm going to multiply by 1.5 or 3/2. Okay, so to find x, I would do this. X equals 1.5 times 6, or 6 times 1.5. 1.5 times 6 is 6 plus 3, or 9. X equals 9, and this was supposed to be a y. Okay, same thing here. Y is going to be 1.5 times 5. Y is 1.5 times 5. 1.5 times 5 is 5 plus half of 5, or 2.5. So that's 7.5. 7.5. Okay, so you'll be asked to find the missing parts of similar triangles. Proportions, scale factors and proportions. All right, and hopefully that helps.